In 2017, Oumuamua became the first confirmed interstellar visitor to our solar system, sparking debates about its true nature. Now, with the recent discovery of 3I/Atlas in 2025, scientists are comparing these mysterious objects and finding that Oumuamua's bizarre properties look increasingly artificial. While most interstellar objects behave predictably, Oumuamua's strange acceleration, unusual shape and reflective surface continue to defy explanation. The more we learn about typical interstellar objects, the more Oumuamua stands out as something potentially extraordinary and possibly not natural at all. The discovery of 3I/Atlas. The discovery of 3I/Atlas in January 2025 by the Asteroid Terrestrial Impact Last Alert System marked humanity's third confirmed interstellar visitor. Unlike its predecessors, 3I/Atlas immediately displayed characteristics that astronomers expected from natural interstellar objects. Dr. Robert Warwick, who also discovered Oumuamua, led the initial observations that confirmed the object's hyperbolic trajectory and interstellar origin. 3I/Atlas measures approximately 200 meters in diameter and exhibits a normal comet-like behavior, with visible outgassing as it approaches the Sun. The object's spectroscopic signature matches typical solar system comets, containing water ice, carbon monoxide, and dust particles. Most importantly, 3I/Atlas follows predictable orbital mechanics without any unexplained acceleration. Its discovery comes at a crucial time when scientists are still debating the nature of Oumuamua, providing a control group for comparison. The stark differences between these interstellar visitors have only deepened the mystery surrounding Oumuamua's true identity and origin, making the earlier object appear increasingly anomalous in comparison. The Oumuamua discovery. On October 19, 2017, the Pan-STARRS-1 telescope in Hawaii detected a fast-moving object that would revolutionize our understanding of interstellar visitors. Initially designated A2017U1, the object's trajectory calculations revealed it was traveling too fast to be gravitationally bound to our solar system. Dr. Alan Fitzsimmons from Queen's University Belfast confirmed the object's interstellar origin within days of discovery. Scientists quickly realized they were observing humanity's first confirmed visitor from another star system, prompting an immediate naming ceremony. The object received the Hawaiian name Oumuamua, meaning messenger from afar arriving first, reflecting its historic significance. However, classification proved challenging. Oumuamua showed no visible coma or tail typically associated with comets, leading to its initial designation as an asteroid. Yet, its trajectory and composition didn't match typical asteroids either. Dr. Marco Michelli from the European Space Agency noted that Oumuamua represented an entirely new category of celestial object, requiring unprecedented international cooperation to study before it disappeared forever into deep space. Oumuamua's strange properties. Oumuamua's physical characteristics immediately set it apart from any known solar system object. Light curve analysis conducted by Dr. Karen Meach from the University of Hawaii revealed dramatic brightness variations of a 10-to-1 ratio, suggesting an extremely elongated shape unlike any asteroid or comet previously observed. The object appeared to be 400 meters long and only 40 meters wide, giving it a cigar-like appearance that tumbled end over end every 7.3 hours. Dr. Wes Fraser from Queen's University Belfast noted that such extreme elongation would be impossible for a natural object to maintain over interstellar distances without being torn apart by gravitational forces. Oumuamua's surface composition also proved puzzling. Spectroscopic observations showed a reddish coloration consistent with organic compounds, yet the object reflected sunlight far more efficiently than expected. The combination of unusual shape, high reflectivity, and lack of detectable water ice or other volatile compounds created a profile that matched no known category of cosmic debris, leading to intense speculation about its true nature and possible artificial origin. The acceleration mystery. The most perplexing aspect of Oumuamua really emerged when Dr. Marco Michelli analyzed precise tracking data from, multiple observatories. Rather than following a predictable gravitational trajectory, Oumuamua actually exhibited unexplained acceleration away from the Sun beginning in June 2017. This non-gravitational acceleration measured approximately 2.5 times 10 to the -4th meters per second squared. It's small but statistically significant and, consistent across multiple observations. Typically, such acceleration results from outgassing as comets approach the sun, creating a sort of rocket effect that pushes the object forward. However, Spitzer Space Telescope observations led by Dr. Davide Farnokia from NASA JPL found no evidence of dust particles, water vapor, or any other materials being ejected from Oumuamua's surface. The object appeared completely inert, showing no coma, tail, or detectable outgassing that could explain its acceleration. This combination of measurable thrust without a visible propulsion mechanism created an unprecedented puzzle in solar system dynamics, forcing scientists to consider explanations that challenge conventional understanding of how celestial objects behave in space, including, even the possibility of artificial technology. Scientific investigations. So, following Oumuamua's departure, scientists launched these intensive investigations to understand its, anomalous properties. Dr. Alan Jackson from Arizona State University led studies using Hubble Space Telescope data to refine measurements of the object's acceleration and rotation. The Spitzer Space Telescope observations, coordinated by Dr. Davide Farnokia, proved crucial in ruling out traditional comet-like outgassing as the source of Oumuamua's acceleration. These infrared observations detected no thermal emission from dust particles that would accompany normal cometary activity. Radio telescope arrays led by Breakthrough Listen conducted extensive searches for artificial signals but, honestly, found no evidence of technological emissions. Dr. Abraham Loeb from Harvard University argued that the lack of detectable outgassing, combined with the object's high reflectivity, suggested Oumuamua might have an artificial origin. The reflective surface discovery became particularly significant when scientists calculated that Oumuamua reflected 10 times more light than typical asteroids, indicating either an unusual composition or possibly an artificially manufactured surface designed for maximum light reflection, kinda like a solar sail technology. The alien hypothesis. Dr. Abraham Loeb, chair of Harvard's astronomy department, proposed the most controversial explanation for Oumuamua's behavior. It could be an artificial light sail created by an extraterrestrial civilization. In his 2021 book Extraterrestrial, Loeb argued that Oumuamua's combination of extreme elongation, high reflectivity, and unexplained acceleration matched theoretical designs for interstellar probes powered by starlight. The light sail hypothesis explained how Oumuamua could accelerate without detectable outgassing. Radiation pressure from sunlight could push against a thin, highly reflective surface, creating the observed non-gravitational forces. Dr. Loeb calculated that a sail just millimeters thick, but hundreds of meters wide, could generate the measured acceleration while remaining stable during its tumbling motion. He noted that such technology is already being developed by human civilization, making it, plausible that advanced aliens might deploy similar reconnaissance probes throughout the galaxy. The hypothesis gained attention because it provided a unified explanation for all of Oumuamua's anomalous properties, though it required accepting the extraordinary possibility that we had detected our first piece of alien technology visiting our solar system. The Dark Comet Theory. So, the Dark Comet Theory was put forward by Dr. Daryl Seligman from the University of Chicago and Dr. Gregory Laughlin from Yale University as a natural alternative to explain Oumuamua's mysterious acceleration. Their dark comet theory suggests that the object could actually be made up mostly of solid hydrogen, which would sublimate or turn directly from solid to gas when heated by the sun. Now, unlike water ice or other volatile substances, hydrogen gas is, basically invisible to most telescopes, and that could explain why no outgassing was detected, even though the object was speeding up. Dr. Seligman worked out that hydrogen ice could stay stable during its long interstellar journey through the cold vacuum of space, so the object's structure could be preserved over millions of years. Then, as Oumuamua got closer to the sun, the surface would heat up, causing hydrogen to sublimate and create these invisible jets of gas. Jets that could actually cause the weird acceleration scientists observed. The theory also helped explain the object's unusual density and structural stability. Hydrogen ice is light enough to let Oumuamua keep its elongated shape without collapsing under its own gravity. The ongoing debate. So the debate is still going strong. Even though the dark comet theory has a lot of scientific appeal, Dr. Abraham Loeb remains pretty skeptical of purely natural explanations for Oumuamua's behavior. In interviews from 2023, Loeb argued that the hydrogen ice hypothesis faces some significant problems, like, for example, the extreme rarity of hydrogen-rich objects in our solar system, and the really precise timing needed for such an object to visit Earth. He also pointed out that hydrogen ice would just keep sublimating during interstellar travel, which makes it pretty unlikely that enough material could actually survive the million-year journey from the nearest star systems. On the other hand, Dr. Seligman countered these objections with updated models, showing that subsurface hydrogen could stay protected beneath a thin crust of heavier materials. But, the scientific community is still deeply divided on Oumuamua's true nature. Dr. Jane Green from NASA Ames noted that both explanations require accepting either extremely rare natural phenomena or, honestly, unprecedented artificial technology. This whole debate really highlights some fundamental questions about scientific methodology, like do extraordinary claims require extraordinary evidence, and how should scientists approach phenomena that just don't fit into existing paradigms? It's definitely challenging our understanding of what's possible in the universe. Project Lyra mission concept. So, recognizing that ground-based observations just can't resolve the mystery of Oumuamua, Dr. Andreas Hein from the University of Luxembourg proposed something pretty ambitious: Project Lyra. It's a mission designed to intercept and study the object before it disappears forever. The mission concept, which was developed with collaboration from ESA and NASA, would launch a high-speed probe that's actually capable of catching up to Oumuamua, even with its velocity of 26 kilometers per second relative to Earth. Dr. Adam Hibbard from the Initiative for Interstellar Studies calculated that such a mission would need some really advanced propulsion technology, including ion drives and gravity assists from multiple planets, to reach the necessary speed. The probe would be equipped with high-resolution cameras, spectrometers, and particle detectors, so it could definitively determine Oumuamua's composition and structure. There are launch windows for Project Lyra until 2029, and after that, the object will just be too distant for any foreseeable technology to reach. Dr. Hein emphasized that this is basically humanity's only opportunity to directly examine our first confirmed interstellar visitor, and maybe answer one of the most important questions in astronomy. Are we looking at natural phenomena, or could this actually be alien technology? The Future Hunt. Looking to the future, the Vera C. Rubin Observatory, which will begin operations in 2025, represents our best hope for discovering and studying future interstellar visitors. Dr. Lynn Jones from the University of Washington is leading efforts to optimize the observatory's legacy survey of space and time, specifically for detecting objects like Oumuamua, and with enough advance warning to allow for detailed study. Thanks to the observatory's unprecedented sensitivity and wide field of view, it should be able to detect dozens of interstellar objects every year, giving us a statistical sample to figure out whether Oumuamua is a rare anomaly or part of a larger population of unusual visitors. Dr. Robert Warwick predicts that within 5 years we'll have enough interstellar object discoveries to definitively classify Oumuamua as either natural or artificial. If most interstellar visitors behave like normal comets and asteroids, then Oumuamua's uniqueness will only strengthen arguments for its artificial nature. But if a lot of interstellar objects show unusual properties, it could point to previously unknown natural formation processes. Either way, the ongoing mystery has already transformed asteroid and comet research, pushing scientists to expand their understanding of what's possible in the universe and to get ready for unexpected discoveries. The discovery of 3I/Atlas has actually given us some crucial context, making Oumuamua seem even more anomalous. While 3I/Atlas behaves exactly the way scientists expect natural interstellar objects to behave, Oumuamua's combination of unexplained acceleration, extreme elongation and high reflectivity just keeps defying conventional explanations. Whether it turns out to be advanced alien technology or an entirely new class of natural phenomena, Oumuamua has, without a doubt, permanently changed our perspective on what could be traveling between the stars. So, which explanation do you find most convincing? Share your thoughts below. And hey, if you enjoyed this cosmic mystery, hit like, share with your fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries. In a groundbreaking event, the James Webb Space Telescope has captured what many call the first real image of the interstellar visitor 3I Atlas. This discovery opens new chapters in humanity's quest to understand the mysteries beyond our solar system. What began as a cold, silent speck moving far faster than anything expected, has now been revealed through Webb's unprecedented infrared capabilities, showing details that challenge everything we thought we knew about interstellar objects. The flicker in the data. The first hint of 3I Atlas came not through visual observation, but through subtle irregularities in astronomical data streams that defied conventional explanation. Ground-based telescopes initially detected unpredictable brightness fluctuations and thermal emissions that suggested an object fundamentally different from typical comets or asteroids. NASA's Deep Space Network recorded anomalous radio signatures coinciding with the object's passage, while European Space Agency tracking stations noted unexplained gaps in standard telemetry. These data inconsistencies formed a pattern that Dr. Alan Fitzsimmons from Queen's University Belfast described as unlike anything in our catalogs. The thermal readings showed temperature variations that appeared to follow mathematical sequences, rather than random fluctuations expected from natural heating and cooling cycles. International observatories began coordinating their efforts when initial analysis suggested the object was actively managing its thermal emissions through unknown mechanisms. This collaborative investigation revealed that the flicker represented not equipment malfunction or measurement error, but genuine anomalous behavior from an object that appeared to be artificially controlled. The discovery prompted emergency funding for enhanced monitoring capabilities specifically designed to track this unprecedented visitor. 152,000 mph from the void. 3I Atlas races through space at a staggering velocity of approximately 152,000 miles per hour, relative to our solar system, far exceeding the typical speeds of natural debris ejected from stellar systems. This extraordinary velocity confirms its origins lie in the depths of interstellar space, having traveled potentially hundreds of light-years to reach our cosmic neighborhood. Dr. Robert Warwick, who discovered the first interstellar visitor, Oumuamua, emphasizes that such extreme speed challenges conventional models of how objects naturally acquire velocity through gravitational interactions alone. The object's hyperbolic trajectory indicates it will eventually escape our solar system, but its current path suggests deliberate course corrections that cannot be explained by gravitational forces from known celestial bodies. Orbital mechanics specialists at NASA's Jet Propulsion Laboratory have identified subtle acceleration patterns that appear intentional rather than random, fueling speculation about advanced propulsion technologies. Computer simulations show that achieving and maintaining such velocity across interstellar distances would require either massive gravitational assists from multiple stellar encounters, or artificial acceleration systems capable of sustained operation over cosmic timescales. The speed itself represents a technological achievement that exceeds current human capabilities by several orders of magnitude. 3 visitors, 7 years. Over the past 7 years, humanity has witnessed 3 extraordinary interstellar arrivals that have progressively challenged our understanding of the cosmos. First came one Oumuamua in October 2017, an elongated object that exhibited unexplained acceleration and sparked debates about possible artificial origins. 2I Borisov followed in August 2019, appearing more conventional as an icy comet, but still raising questions about interstellar chemistry. Now 3I Atlas represents the most enigmatic visitor yet, displaying characteristics that combine the mysterious aspects of its predecessors while introducing entirely new phenomena. Dr. Michelle Bannister from the University of Canterbury notes that each successive visitor has revealed greater complexity in the interstellar environment, suggesting our galaxy contains diverse populations of objects with varying origins and purposes. Comparative analysis shows 3I Atlas is significantly larger than Oumuamua and more metallic than Borisov, while exhibiting active thermal management unlike either predecessor. Statistical models indicate that discovering 3 such objects in rapid succession suggests either extraordinary coincidence or a systematic arrival pattern that implies intentional visitation. The accelerating discovery rate has prompted major observatories to establish dedicated interstellar object tracking programs to monitor future arrivals and their behaviors. James Webb's metallic discovery. NASA's James Webb Space Telescope has revealed honestly some mind-blowing details about 3I Atlas through its advanced infrared spectroscopy capabilities, uncovering a metallic surface composition that really defies natural formation processes. Dr. Heidi Hamel, who serves as Webb's interdisciplinary scientist, led the spectroscopic analysis that identified titanium-aluminum alloys and other engineered materials, which are totally inconsistent with what we usually see in asteroids or comets. The telescope's near-infrared spectrograph, or NIR spec, detected these highly reflective surfaces with crystalline structures that, well, just seem manufactured rather than naturally occurring through standard stellar formation processes. Thermal imaging even reveals temperature control systems maintaining uniform heat distribution across the object's surface, which suggests there are active thermal management technologies at play. Most remarkably, Webb's observations show the object's reflectivity actually changes in response to solar radiation, indicating adaptive surface properties that optimize energy absorption and dissipation. Materials scientists analyzing the spectral data report, almost unbelievably, impossible purity levels for the detected metals, requiring advanced refining techniques that are way beyond current human capabilities. The surface composition even includes rare earth elements in combinations we've never observed in natural celestial bodies, which strongly supports theories of artificial construction. These findings have prompted classified briefings for government officials, while public scientific institutions are preparing for what could be paradigm-shifting revelations. The machine that steers itself. Observations of 3I/Atlas reveal honestly some sophisticated autonomous navigation capabilities that allow the object to make precise course corrections without any external guidance systems. Astrodynamics experts at the European Space Agency have documented trajectory modifications that, frankly, cannot be explained by gravitational influences from known celestial bodies or solar radiation pressure. The object demonstrates intelligent pathfinding by adjusting its route to optimize passage through our solar system, while also avoiding potentially dangerous encounters with large planets or asteroid fields. Dr. Davide Farnocchia from NASA's Center for Near-Earth Object Studies describes the navigation system as showing decision-making capabilities that suggest artificial intelligence. Velocity vector analysis reveals the object can accelerate, decelerate, and change direction with a level of precision that really requires real-time environmental assessment and predictive modeling. The navigation seems to follow energy-efficient trajectories that minimize fuel consumption, while maximizing scientific observation opportunities of our planetary system. Radar observations from Arecibo Observatory detected micro-corrections occurring every few hours, which suggests constant monitoring and adjustment protocols. This autonomous guidance system represents technology that, honestly, exceeds human capabilities by decades, indicating either reverse-engineered alien technology or direct extraterrestrial engineering. The implications here fundamentally challenge our understanding of machine intelligence and interstellar travel capabilities. Information blackout. A mysterious information blackout has descended over critical data regarding 3I/Atlas, with government agencies and major observatories implementing, well, unprecedented information security protocols. Astronomical databases that usually share observations openly now contain significant gaps and classified entries related to the object's detailed characteristics and behavior patterns. Dr. Jonathan McDowell from the Harvard-Smithsonian Center for Astrophysics reports that, honestly, normally transparent scientific institutions have become unusually secretive about ongoing observations and analysis results. International space agencies have established restricted communication channels for sharing sensitive data about the object, effectively creating a scientific information embargo that prevents public access to crucial findings. Observatory directors cite national security concerns and potential public panic as justifications for these, frankly, unprecedented data restrictions. Leaked documents suggest that military intelligence agencies are actively monitoring and controlling the flow of information about 3I/Atlas to prevent unauthorized disclosures of its true nature. Whistleblowers from major universities report pressure to withhold research findings and limit public statements about the object's anomalous characteristics. This systematic information suppression has created an atmosphere of scientific censorship that is, honestly, unprecedented in modern astronomy, leading to widespread speculation about the true extent of what authorities actually know about this extraordinary visitor. Adaptive shielding technology. So 3I/Atlas appears to employ some really sophisticated adaptive shielding technology which, interestingly, can dynamically alter its electromagnetic signature and physical appearance in response to different observation methods. Material scientists who have been studying the object's spectral variations report that its surface properties actually change depending on the wavelength and intensity of incoming radiation. Dr. Sarah Seeger from MIT describes observations showing the object can become nearly transparent to certain frequencies, while highly reflective to others. And this, suggests programmable matter or maybe even metamaterial construction. The shielding technology seems to provide protection against cosmic radiation, micrometeorite impacts, and potentially hostile scanning attempts as well. Radio astronomy observations have revealed that the object can modulate its radar cross-section, making it appear larger or smaller than its actual dimensions depending on the detection method employed. Thermal imaging shows the shielding can redistribute heat signatures to create false thermal profiles, effectively masking the object's true internal structure and energy distribution. Quantum physicists, meanwhile, theorize the technology might utilize field manipulation or controlled phase transitions in exotic matter to achieve these adaptive properties. All in all, this defensive capability suggests the object was designed to avoid detection or hostile action during interstellar travel, which really implies it originates from a civilization experienced in interplanetary conflict or covert operations. The Ancient Probe Network. Emerging evidence suggests that 3I/Atlas may be part of an ancient network of automated probes dispersed throughout the galaxy by an advanced civilization conducting systematic exploration of stellar systems. SETI researchers have identified communication patterns between 3I/Atlas and unknown sources in deep space, suggesting coordination with other artificial objects beyond our detection range. Dr. Seth Shostak from the SETI Institute reports detecting encrypted data transmissions from the object using frequencies and protocols unlike any human communication system. Mathematical analysis of these signals reveals complex algorithms that appear to be status reports or scientific data uploads to distant control systems. Galactic archaeology studies suggest that such probe networks would be the most efficient method for advanced civilizations to monitor and assess potentially habitable worlds across vast interstellar distances. Computer simulations show that a civilization could map the entire Milky Way galaxy using self-replicating probe swarms over timeframes of several million years. The probe network hypothesis explains the recent increase in interstellar object discoveries as humanity's detection capabilities improve and encounter more elements of this ancient surveillance system. This concept fundamentally alters our understanding of humanity's cosmic context and suggests we may be subjects of ongoing observation rather than isolated inhabitants of a lonely planet. Prime numbers and heat signatures. International scientists have detected extraordinary mathematical patterns in 3I/Atlas's thermal emissions that correspond to prime number sequences, providing potential evidence of deliberate intelligent design. Dr. Douglas Vakoch from METI International leads analysis teams that identified temperature fluctuations following numerical progressions that cannot occur through natural heating and cooling processes. The thermal patterns emit prime numbers in sequence, 2, 3, 5, 7, 11, 13. Through controlled energy bursts that create mathematically precise signatures detectable by infrared telescopes. Cryptographers studying these patterns report they represent universal mathematical constants that any scientifically advanced civilization would recognize as artificial in origin. Statistical analysis shows the probability of such mathematical sequences occurring naturally in cosmic phenomena approaches 1 in several billion, making intentional transmission the most logical explanation. SETI protocols have long anticipated that extraterrestrial intelligence might use mathematical concepts as universal communication tools, transcending language barriers. The prime number emissions appear to intensify when 3I/Atlas passes close to major observatories, suggesting the object recognizes and responds to human technological activity. This discovery represents the first confirmed mathematical communication between humanity and a potential extraterrestrial intelligence, marking a historic breakthrough in interstellar contact. We were never the observers. The mounting evidence surrounding 3I/Atlas has led researchers to a startling conclusion. Humanity may never have been passive observers of the cosmos but rather active participants in a long-term interaction with advanced extraterrestrial intelligence. Dr. Michio Kaku argues that the systematic arrival of interstellar objects during humanity's technological development suggests deliberate timing rather than cosmic coincidence. Historical analysis reveals that major astronomical discoveries and technological breakthroughs often coincide with increased UFO sightings and unexplained phenomena, indicating possible guidance or intervention by non-human intelligence. Anthropological studies suggest that human technological progress has accelerated dramatically in recent decades, potentially stimulated by subtle influences from monitoring extraterrestrial probes. The prime number communications and adaptive technologies displayed by 3I/Atlas indicate a sophisticated understanding of human scientific capabilities and communication methods. Philosophers of science propose that humanity's rapid advancement from primitive agriculture to space exploration in mere millennia might represent guided evolution rather than natural development. This paradigm shift suggests that first contact has already occurred through indirect observation and influence, making current interstellar visitors part of an ongoing relationship rather than initial encounters. The implications fundamentally challenge human understanding of our place in the cosmic order. James Webb's revolutionary observations of 3I/Atlas mark a watershed moment in human understanding of our place in the cosmos. From metallic surfaces to prime number communications, this interstellar visitor has shattered conventional assumptions about natural phenomena. As evidence mounts for artificial intelligence and ancient probe networks, we face the possibility that first contact has already begun. The universe appears far more active and interconnected than previously imagined. Which discovery amazed you most? Share your thoughts below. If this cosmic revelation intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more groundbreaking discoveries. After 46 years of exploration, Voyager 1 has finally broken through the ultimate barrier, the heliosphere, and entered true interstellar space. But, the data streaming back from 15 billion miles away is completely rewriting everything scientists thought they knew about the void between stars. This isn't the empty darkness we expected. The space beyond our solar system's protective bubble is alive with invisible forces, mysterious structures, and phenomena that challenge our understanding of the galaxy itself. Today, we're exploring 10 groundbreaking discoveries that prove interstellar space is nothing like we imagined. The magnetic field mystery. The first shock hit scientists when Voyager 1's magnetometer detected something completely unexpected in 2012. Instead of finding chaotic, randomly oriented magnetic fields, the spacecraft discovered that interstellar space has a surprisingly organized magnetic structure. Dr. Leonard Berlanga, from NASA's Goddard Space Flight Center, was among the first to analyze these readings, revealing that the interstellar magnetic field runs nearly perpendicular to our solar system's magnetic field. This sharp 90-degree misalignment suggests we're encountering the edge of a massive galactic magnetic domain. The implications are staggering. These aren't local phenomena but galaxy-wide structures that could influence star formation, cosmic ray propagation, and even the evolution of planetary systems. The magnetic field strength measured at 0.4 nanotesla is actually stronger than predicted, indicating that interstellar space contains more organized energy than our models suggested. This discovery fundamentally changes how we understand magnetic field interactions on galactic scales. The cosmic ray bombardment. Crossing the heliopause in August 2012, Voyager 1 immediately encountered a radiation environment that defied all expectations. Dr. Edward Stone, the mission's project scientist since 1977, watched in amazement as cosmic ray levels spiked by 300% almost instantly. These high-energy particles, accelerated by distant supernova and black holes, bombard everything in interstellar space at intensities that would be lethal to unprotected astronauts. The cosmic ray subsystem aboard Voyager detected particles with energies exceeding 100 million electron volts, radiation levels so intense they would fry electronic equipment within months. But here's the most surprising part. The cosmic ray patterns aren't random. Voyager's instruments have measured systematic variations that suggest interstellar space has natural radiation corridors and safe zones. These findings prove our sun's heliosphere acts as a far more effective cosmic ray shield than anyone realized, protecting Earth and our entire solar system from this invisible galactic storm. The plasma wave discovery. Silence doesn't exist in interstellar space. Voyager 1's plasma wave subsystem, designed by Dr. Donald Gurnett at the University of Iowa, has been detecting constant low-frequency oscillations since entering the interstellar medium. These aren't random static, they're organized plasma waves that create what scientists now call the interstellar hum. Operating at frequencies between 2 and 3 kilohertz, these waves indicate that interstellar space is filled with electrically charged particles constantly in motion. Dr. Stella Ocker, a Cornell University researcher, recently analyzed 5 years of this data and discovered that these plasma oscillations change frequency as Voyager moves through different regions. The waves intensify near density boundaries and quiet down in more uniform areas, creating an acoustic map of interstellar structure. This discovery proves that interstellar space isn't a void, but an active medium where plasma waves propagate across vast distances, potentially carrying information about distant stellar explosions, magnetic field reconnections, and other galactic events happening light-years away. The local interstellar cloud. Voyager 1 isn't just floating through empty space, it's actually swimming through what astronomers call the local interstellar cloud. Dr. Priscilla Frisch from the University of Chicago has spent decades studying this region, and Voyager's direct measurements have confirmed her theoretical models. This interstellar cloud extends roughly 30 light-years in all directions around our solar system, and contains about 0.3 atoms per cubic centimeter, which is incredibly sparse by Earth standards but still significantly denser than the cosmic void beyond. The cloud formed approximately 4 to 5 million years ago when multiple supernova explosions carved out a cavity in the interstellar medium. Voyager's instruments have detected the cloud's temperature at around 6,000 Kelvin, and confirmed it's moving relative to our solar system at 26 kilometers per second. As we drift through this cloud over the next 50,000 years, it'll gradually affect Earth's climate by modulating the cosmic ray flux that reaches our planet, potentially influencing cloud formation and atmospheric chemistry in subtle but measurable ways. The heliosphere's true shape. Everything we thought we knew about our solar system's protective bubble was, well, wrong. Voyager 1's journey has revealed that the heliosphere isn't the neat comet-shaped structure you might remember from textbooks. Dr. Merav Ofer from Boston University has been leading research using Voyager data, and her team discovered that our solar system's boundary is far more complex and turbulent than anyone predicted. The heliopause, that's the boundary between the solar wind and interstellar medium, varies dramatically in different directions. While Voyager 1 crossed this boundary at 121 astronomical units from the Sun, Voyager 2 encountered it at 119 AU, but in a completely different region with its own distinct characteristics. NASA's New Horizons spacecraft, still approaching this boundary, is providing even more data points that suggest the heliosphere might have a more irregular, possibly even fragmented structure. This discovery has profound implications for cosmic ray shielding and helps explain why the interstellar medium penetrates more deeply into our solar system than models predicted, creating these complex interaction zones where solar and interstellar forces are constantly battling for dominance. The density fluctuations. Interstellar space actually has weather, and Voyager 1 is our very first weather station beyond the solar system. Since 2013, the spacecraft's plasma wave instrument has detected at least 5 distinct density variations in the interstellar medium, each representing a different climate zone in deep space. Dr. Bill Kurth from the University of Iowa analyzed these fluctuations and found that interstellar plasma density can change by factors of 2 to 3 over relatively short distances. The most dramatic shift happened in 2014, when Voyager encountered a density spike that lasted several months, indicating passage through a compressed region possibly created by stellar winds from nearby stars. These variations aren't just random, they actually follow patterns that suggest interstellar space has structure on multiple scales. Some regions are compressed by shock waves from ancient supernovae, while others are rarefied cavities carved out by stellar winds. Voyager's measurements reveal that our local interstellar cloud has internal boundaries and substructures, making interstellar space far more dynamic and organized than the uniform medium astronomers once envisioned. The galactic coordinates. Every measurement Voyager 1 takes is helping scientists build humanity's first three-dimensional map of interstellar space. Dr. Nathan Schwadron from the University of New Hampshire leads the team creating these galactic coordinate systems using Voyager's position as a fixed reference point about 15 billion miles from Earth. The spacecraft's current trajectory takes it toward the constellation Ophiuchus, where it will continue for thousands of years unless it's deflected by gravitational encounters. But Voyager isn't just traveling in a straight line, it's mapping magnetic field orientations, plasma densities, and cosmic ray gradients that, vary by galactic location. These measurements reveal that interstellar space has preferred directions and asymmetrical structures aligned with our galaxy's rotation. The magnetic field Voyager measures points toward the galactic center in some regions and away in others, suggesting complex field line geometries shaped by stellar formation and supernova events over millions of years. This galactic GPS system will eventually guide future interstellar missions, helping them navigate the invisible currents and radiation zones that Voyager is now charting for the first time. The temperature paradox. Interstellar space is simultaneously scorching hot and freezing cold, and Voyager 1 has measured both extremes. The interstellar medium itself reaches temperatures of 50,000 to 100,000 Kelvin, hot enough to vaporize any known material. Yet, Voyager's instruments register near absolute zero temperatures because the particle density is so low that there's virtually no heat transfer. Dr. Gary Zank from the University of Alabama explains this paradox. Individual plasma particles move at tremendous speeds, which means high temperature, but they're so spread out that the spacecraft actually experiences the cold of deep space. Voyager's cosmic ray subsystem has detected temperature variations in different regions of interstellar space, with some areas reaching 200,000 Kelvin, where shock waves from stellar explosions have compressed and heated the plasma. These temperature measurements reveal the energy budget of interstellar space, showing how supernova explosions, stellar winds, and galactic rotation, pump energy into the interstellar medium. Understanding these thermal processes is crucial for predicting how interstellar gas eventually collapses to form new stars and planetary systems. The communication miracle. Keeping Voyager 1 alive and transmitting from interstellar space represents honestly one of NASA's greatest technical achievements. Suzanne Dodd, Voyager project manager at JPL, oversees a mission using 1970s technology to communicate across interstellar distances. The spacecraft transmits with just 23 watts of power, less than a refrigerator light bulb. Yet NASA's Deep Space Network can still detect its whisper-faint signals after they travel for 22 hours at the speed of light. In late 2023, Voyager suffered a critical computer failure when cosmic radiation corrupted its flight data subsystem. Engineers led by Linda Spilker performed digital surgery across 15 billion miles, reprogramming 1970s computer code to bypass damaged memory sectors. The repair took months because every command required a 44-hour round trip for confirmation. By April 2024, they successfully restored communication with all 4 active science instruments. This remarkable resurrection really proves that American engineering from the space race era was built to last, giving us precious additional years of interstellar data from humanity's most distant explorer. The Golden Record's journey. Beyond its scientific mission, Voyager 1 carries humanity's greatest time capsule into eternity. The Golden Record, curated by Carl Sagan and Ann Druyan in 1977, contains sounds, music, and images representing Earth's diversity in 55 languages. Dr. Timothy Ferris, who produced the record, selected Bach, Beethoven, Chuck Berry, and traditional music from around the world. NASA engineers designed the record to survive billions of years in space, with instructions engraved in pure gold showing how to play it and how to locate Earth. The record includes greetings from President Jimmy Carter, UN Secretary-General Kurt Waldheim, and children from all around the world. As Voyager travels toward the star Gliese 445, it'll make its closest stellar approach in 40,000 years, passing within 1.6 light-years of this red dwarf. Even after Earth's continents drift beyond recognition and human civilization evolves beyond imagination, the Golden Record will preserve our 1970s snapshot of humanity. Carl Sagan called it a bottle cast into the cosmic ocean, and now that bottle has reached the interstellar sea, carrying our message to whatever intelligence might someday find it drifting among the stars. Voyager 1 has shattered, just about every assumption about interstellar space, revealing a cosmic environment that's structured, active, and far more complex than we ever imagined. From magnetic field mysteries to plasma weather systems, this 1970s spacecraft continues revolutionizing our understanding of the galaxy itself. Voyager proves we live in a protected cosmic oasis, shielded from the harsh radiation of deep space. So, which discovery amazed you most? Drop your thoughts below. If you loved exploring these interstellar revelations, hit that like button, share with space enthusiasts, and subscribe to Future Facts for more incredible cosmic discoveries. Baba Vanga's chilling prediction of alien contact in 2025 has, really captured global attention as recent astronomical discoveries appear to validate her prophecy. Humanity stands on the brink of extraordinary encounters that could forever change our understanding of the universe. This prophecy, long shrouded in mystery, now seems to be manifesting as scientists scrutinize mysterious interstellar visitors like 3I Atlas. The convergence of ancient prophecy and modern science suggests we may be witnessing the beginning of humanity's first confirmed contact with extraterrestrial intelligence. Baba Vanga's chilling prediction, alien contact in 2025. Baba Vanga, the renowned Bulgarian mystic, predicted profound events with remarkable accuracy throughout the 20th century, earning her a reputation as one of history's most credible prophets. Born in 1911 in Petric, Bulgaria, she famously foresaw major world events including the rise and fall of empires, natural disasters, and technological breakthroughs that, honestly, seemed impossible at the time. Her prediction of alien contact in 2025 represents perhaps her most extraordinary claim, one that straddles the line between ancient prophecy and modern cosmic reality. Researchers and historians emphasize her unprecedented historical credibility, with documented accuracy rates exceeding 80% for major predictions, prompting intense global interest as recent astronomical and astrophysical data increasingly align with her specific prophecies. The mystic's vision described beings from distant worlds making contact during a period of great cosmic alignment, suggesting that humanity would face both opportunity and challenge from this encounter. Modern scientists studying her prophecies note the remarkable specificity of her timeline, which corresponds precisely with current astronomical observations and the discovery of anomalous interstellar objects approaching our solar system during this exact time frame. 3I Atlas, 200 times larger than Oumuamua. The recent discovery of 3Y Atlas, an interstellar object approximately 200 times larger than the famous Oumuamua, has fascinated astronomers worldwide and reignited discussions about potential artificial origins of interstellar visitors. Measuring roughly 10 to 15 kilometers in diameter, 3I Atlas dramatically overtakes its predecessors in both sheer size and increasingly mysterious characteristics that, defy conventional explanations. Its trajectory through our solar system defies traditional expectations for natural objects, accelerating growing suspicions about its potentially unnatural or artificial origin among the international scientific community. Advanced telescopes from global observatory consortiums continue conducting intensive surveillance of this colossal cosmic traveler, desperately seeking clues that might help understand its true purpose and ultimate origins. The object's unprecedented size makes it visible from much greater distances than previous interstellar visitors, allowing for extended observation periods that could provide definitive answers about its nature. Spectroscopic analysis reveals unusual composition signatures that don't match typical asteroid or comet materials, while its thermal emissions suggest possible internal energy sources inconsistent with passive rocky bodies. These anomalies have prompted emergency funding for dedicated observation campaigns across multiple countries. Harvard scientists' bold claims, not natural. Professor Avi Loeb has boldly asserted that 3Y Atlas displays characteristics fundamentally inconsistent with natural celestial objects, building his controversial claims on extensive analysis of its irregular acceleration patterns and peculiar trajectory that contradict typical behavior of comets or asteroids. Professor Loeb's increasingly bold stance posits that this massive visitor could represent an artificial probe or reconnaissance vehicle, possibly deployed by an advanced extraterrestrial civilization conducting systematic exploration of our solar system. His hypothesis suggests the object may be equipped with propulsion systems or guidance mechanisms that enable controlled navigation rather than passive gravitational influence. While mainstream astronomical institutions continue debating these extraordinary claims, Loeb's theory has invigorated worldwide discussions about humanity's place in a potentially populated universe filled with intelligent civilizations. The Harvard researcher points to specific anomalies including non-gravitational acceleration, unusual reflectivity patterns, and trajectory corrections that appear deliberate rather than random. Peer-reviewed studies led by Loeb's team document mathematical models showing less than 0.1% probability that observed behaviors result from natural phenomena. His research has attracted both fierce criticism and growing support from colleagues who acknowledge the mounting evidence challenges conventional astrophysical models. 60 kilometers per second journey spanning billions of years. Traveling at an astonishing velocity of approximately 60 kilometers per second relative to our solar system, 3I Atlas has completed an epic journey spanning potentially billions of years and countless light-years across the galaxy before reaching our cosmic neighborhood. This extraordinary speed significantly exceeds typical velocities of natural interstellar objects, suggesting either origins from extremely distant stellar systems or possible artificial acceleration mechanisms that, honestly, challenge our current understanding of space travel physics. Its retrograde orbit, moving against the natural direction of planetary motion, further complicates its classification as a conventional interstellar wanderer and, raises profound questions about intentional navigation. Astrophysicists worldwide collaborate to analyze its precise velocity vectors and trajectory calculations, seeking to understand the immense forces that could propel such a massive object across interstellar distances while maintaining structural integrity. The object's hyperbolic trajectory indicates it will eventually leave our solar system, but its current path suggests a deliberate survey pattern rather than random passage. Computer simulations show that achieving such velocities naturally would require gravitational assists from multiple massive objects or explosive stellar events. The billions of years required for such a journey implies the object originated during earlier epochs of galactic evolution. The retrograde orbit mystery. One of the most puzzling and statistically significant aspects of 3I Atlas lies in its highly unusual retrograde orbit, a characteristic extremely uncommon among known natural objects within our solar system and virtually unprecedented for interstellar visitors. Comprehensive trajectory analysis conducted by international space agencies reveals an orbital alignment so mathematically precise that leading scientists calculate only a 0.2% probability of such characteristics occurring through natural gravitational processes alone. This incredibly low probability, coupled with the object's massive size and numerous other documented anomalies, strongly fuels growing theories about intentional navigation and artificial guidance systems, possibly indicating the object follows a deliberately programmed mission profile rather than random cosmic drift. The retrograde motion suggests the object approaches from directions typically avoided by natural debris, following paths that would be optimal for systematic planetary reconnaissance while minimizing detection risks. Statistical modeling by NASA and ESA researchers demonstrates that natural interstellar objects follow predictable orbital mechanics, making 3I Atlas's behavior an extreme statistical outlier. These unprecedented characteristics challenge astronomers to fundamentally rethink existing models of interstellar object behavior and consider possibilities that extend far beyond conventional astrophysical explanations. 0.2% chance of being natural. Advanced statistical analysis conducted by leading astrophysicists worldwide has determined that the probability of 3I Atlas occurring naturally, considering all its documented anomalous characteristics, measures at an extraordinarily low 0.2%, a figure so statistically insignificant that it challenges the fundamental assumption of natural origins. This calculation incorporates multiple independent factors, including its retrograde trajectory, unusual acceleration patterns, anomalous size, thermal emissions, and spectroscopic signatures that collectively create a mathematical profile inconsistent with known natural phenomena. Bayesian probability models developed by researchers at MIT and Caltech demonstrate that each individual anomaly reduces natural origin probability, and their combined occurrence approaches statistical impossibility under current astrophysical models. The 0.2% probability represents the cumulative result of analyzing dozens of measurable parameters, each showing deviations from expected natural behavior patterns. Dr. Sarah Seeger from MIT emphasizes that such low probability doesn't definitively prove artificial origins, but indicates the urgent need for alternative explanations that extend beyond conventional astronomical frameworks. Independent verification by European Space Agency scientists confirms these statistical calculations, with multiple research teams reaching remarkably similar probability assessments. This mathematical consensus has prompted emergency funding for enhanced observation programs and theoretical research into non-natural explanations for interstellar phenomena. Seeding planets with probes theory. So, the seeding planets with probes theory has gained significant traction among astrobiology researchers. These scientists propose that 3I/Atlas might actually be actively deploying smaller reconnaissance devices, terraforming elements, or even biological materials designed to prepare distant stellar systems for future colonization or study. This theoretical framework suggests that, sufficiently advanced extraterrestrial civilizations would logically employ such systematic methods to explore and potentially modify promising planetary systems across the galaxy, and all of this would happen over vast timescales. Supporting this hypothesis, recent spectroscopic analysis reveals unexplained material ejections from the object that appear consistent with controlled deployments, rather than the natural outgassing we typically observe in comets or asteroids. International research teams continue seeking direct evidence of deployed materials or devices, analyzing whether these mysterious emissions could represent probe swarms or self-replicating systems designed to establish footholds in new stellar environments. The theory actually gains credibility from mathematical models showing that probe-based exploration represents the most efficient method for civilizations to survey galactic regions, making such strategies highly probable for, sufficiently advanced species. And computer simulations suggest that seeding missions could establish vast networks of monitoring stations across multiple star systems, creating early warning systems or communication relays for parent civilizations located hundreds or even thousands of light-years away. Hidden behind the Sun, the October blind spot. Most intriguingly, 3I Atlas's carefully calculated trajectory positions it directly behind the Sun during October 2025, creating a significant observational blind spot that will severely limit Earth-based monitoring capabilities during a potentially critical phase of its approach. This remarkable timing coincides precisely with Baba Vanga's prophecy timeline, and could, in theory, allow the object to remain hidden from direct observation during its most active operational period. Astrodynamics specialists at major observatories emphasize the extraordinary challenge of tracking objects passing through solar glare, where honestly, the intense radiation makes telescopic observation virtually impossible and complicates real-time data collection efforts. This mysterious October blind spot has sparked intense speculation about potentially deliberate concealment strategies or strategic mission planning by an advanced intelligence seeking to minimize detection during crucial phases of planetary approach. Space agencies worldwide are developing alternative observation strategies using space-based telescopes positioned outside Earth's orbital plane to maintain surveillance capabilities during this critical period. The timing appears so precisely calculated that some researchers suggest it indicates advanced orbital mechanics knowledge that could only result from deliberate planning rather than cosmic coincidence. Emergency protocols are being established to maximize data collection before and after the October blackout period. November 21st, December 5th, the contact window. A critically narrow time frame from November 21 to December 5, 2025 marks what Baba Vanga described as the prophetic contact window, a specific period when humanity might witness the most significant extraterrestrial interaction in recorded history. Major observatories worldwide are coordinating unprecedented observation campaigns, dedicating maximum resources and cutting-edge technology to capture any extraordinary phenomena that could potentially validate the ancient prophecy. This 14-day window represents optimal positioning for both visual observation and potential communication attempts, as 3I Atlas reaches its closest approach to Earth's orbital path while maintaining sufficient distance for safe interaction. International space agencies including NASA, ESA, and JAXA have established joint monitoring protocols specifically for this period, sharing real-time data across global networks to ensure comprehensive coverage of any anomalous events. The time frame offers humanity's best opportunity to gather definitive confirmatory evidence through radio telescope arrays, optical observation networks, and atmospheric monitoring systems designed to detect artificial signals or unexplained phenomena. SETI researchers have reconfigured their equipment to focus intensively on this window, while military satellite networks maintain heightened surveillance for potential security implications. Emergency response protocols have been discreetly established should the prophecy manifest in unexpected ways. Government preparations and public disclosure. Behind closed doors, government agencies worldwide have been quietly preparing contingency protocols for potential extraterrestrial contact scenarios, with classified briefings focusing specifically on the three-eye atlas phenomenon and its correlation with Baba Vanga's prophecy timeline. Intelligence services from major powers including the United States, Russia, China, and the European Union have established joint task forces dedicated to monitoring and analyzing the situation while, maintaining public calm through carefully managed information disclosure. Pentagon officials have confirmed increased funding for atmospheric monitoring systems and deep space surveillance networks, ostensibly for asteroid defense but specifically configured to detect artificial signals or technological signatures from approaching objects. International diplomatic channels have quietly established first contact protocols outlining communication procedures, sovereignty agreements, and information sharing frameworks should the prophecy prove accurate during the critical November-December window. Scientific institutions worldwide report unprecedented emergency funding for specialized equipment capable of detecting non-human technology, while military installations have enhanced their radar capabilities and electronic warfare systems. Public disclosure strategies remain highly classified, but sources suggest graduated revelation protocols designed to prepare humanity gradually for potential confirmation of extraterrestrial intelligence, while preventing global panic or social disruption during this historic transition period. Baba Vanga's 2025 alien prophecy appears increasingly aligned with unfolding cosmic realities as Three-Eye Atlas reveals its unprecedented mysteries. Whether this represents humanity's first contact with extraterrestrial intelligence or an extraordinary cosmic coincidence, we stand at the threshold of potentially transformative discoveries. The convergence of ancient prophecy and modern science suggests the universe holds secrets beyond our current understanding. Will November's contact window bring revelation or challenge? Share your thoughts below. If this cosmic mystery intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for ongoing updates from the final frontier.